Hey guys, so it's our first week learning about this thing called plate tectonics. This is probably going to close us out through the year. This unit, and then we're going to talk a little bit about Earth's history at the end of the year officially. So on the board or on the TV is a specific mountain, a special mountain that is currently the tallest mountain in the world. So there's some interesting things about the tallest mountain in the world. First off, its name is Mount Everest. It's part of the Himalayan mountain chain that's between India and China and that general region. So pretty much southern Asia. Um, Really interesting thing about the tallest mountain on Earth, the highest peak, is that not this top layer here, but underneath it, the second to the highest layer, those rocks are really interesting because inside these rocks that are on the highest point are these giant fossils of shells. So these giant shelled fossils, so they're like pretty much clams. And when we think about clams, where do clams exist? Clams exist underwater, right? So the only thing that would make sense is that this layer of rock here, a sedimentary rock that forms underwater, and that has fossils of shelled organisms that only exist underwater, must have formed underwater. So that gives us two options. Either the ocean was up this high, 5 miles high above the earth, well, above where sea level is now, or this used to be low and has been uplifted to its new position. So turns out there's not enough water on Earth in order for there to be nearly enough to cover up to that point. So that means that these rocks formed under the ocean, and they're now currently, due to some type of uplift, has become the tallest mountain on the Earth, Mount Everest. So I just think that's really cool. So we're going to talk about this thing called plate tectonics, or continental drift, right? And that's just the idea that the Earth is changing, and it changes very, very slowly compared to us. So our lives are 70 years, 100 years on average, right? Something in that range. And that seems like a long amount of time, but when it comes down to the Earth's age and comparing it relatively to the Earth's age, we exist in a short period of time. The Earth is 4.6 billion years old. We live until we're 70 years old. So if there's changes that's happening on the Earth that occur over this long period of time, we don't even really notice it. We just notice subtle little things like earthquakes and that volcanoes erupt. But that process of earthquakes and volcano erupting are slow processes that are going to be dragged out. My cat wants to go. Oh my God, dude. All right, so Earth's crust, or Earth's outer part that we stand on, is not made of one solid piece. It's made up of these individual things called plates. And these plates slowly move and slowly drift, and they cause earthquakes every time they do move. But these plates move very, very slowly. They move about 2 to 5 centimeters per year. So 2 to 5 centimeters per year. And we're talking about entire continents, entire oceans moving at this rate. So this is very, very slow, and it's the same rate at which your fingernails grow, which is gross, but that's a good understanding of how slow it is. We don't know that you can't watch your fingernails grow, but you know they move, and you know they do grow. But it's just very, very slow. So this is from the reference table. It has all the different plates. We live on the North American plate. We're right here in New York, and we're not along any plate boundary. Wherever you see a line, that's a boundary between two different plates. This is why we don't experience really dramatic earthquakes. Those dramatic earthquakes are always going to occur, mostly going to occur along these plate boundaries, like in California, right, where they have the San Andreas Fault, and there's a lot of tectonic activity around this area. So we're going to talk about a little bit about the history of the Earth, but one thing to know is that the Earth's crust, the area that we stand on, is very, very thin compared to the rest of the Earth. Okay, so it's in some areas going to be 5 miles thick, in some areas it's going to be 50 miles thick. But to understand how that compares to the size of the Earth, imagine an apple. So if I cut an apple in half then the skin of the apple is going to be, really, really thin. And that's what you can think of as the thickness of the Earth's crust compared to the rest of the interior of the Earth. So it's very, very thin. This little black line is representing the entire crust. Very thin stuff. All right, so interesting stuff. The continents used to all be touching. Now, when we look at a picture like this of South America and Africa, if it was the 1940s or the 1950s, and you said to your elementary school teacher, hey, it looks like South America and Africa fit together like puzzle pieces, right? You see that border right there? And you see that border right there? Your teacher would have said, no, plates or continents can't move, that's impossible. But now we understand that they actually have moved. And that's going to be something that we're going to explore a little later on, but the puzzle pieces is part of that. Also, these areas show where we have similar fossils of organisms on South America and Africa, India, Antarctica, and Australia. And the only way that these organisms that couldn't swim could be on the same or two different continents was that these continents were just once touching. No animal is going to be able to swim across this unless it's like a sea animal, unless it exists in the ocean. Okay? So here's an image of South America and Africa, the actual continent that is kind of underwater, but it still is part of the continent, and it fits together even better as puzzle pieces. Almost done. About 200 million years ago, Pangaea existed. Pangaea was when all the continents, Europe, Asia, North America, South America, Africa, India, Antarctica, Australia, all the continents were once touching. Pan, like pandemic, Pan means across the earth, so all the earth. And then Gaea means earth, right? So Pan is everything around, and Gaea is earth. So Pangaea literally means all of earth. So everything was in one spot, all right? And it looked like this. If you had a satellite image of that, it would look like this. This is what a map image would look like. Here's North America, South America, Africa, Europe, Asia, India, Antarctica, Australia. And here's an image of the plates today, nice and colored, all right? So we have Earth's crust, which is what we stand on. Underneath that is this asthenosphere, which is part of Earth's mantle. And here's what you can think of as the crust, mantle, outer core, inner core. We stand on the crust, and we also call that solid piece of rock the lithosphere. Okay? So that's all I got for you today. Try out that Nearpod. Enjoy it. Take it easy. Have a good one.